Finally, we're going to look at volume of a sphere. Now, I would love to develop the formula for you, but the mathematics are actually a little bit higher, and in calculus you can actually develop it. And you'll get the formula, volume equals 4/3 pi r cubed, where r is the radius of the sphere. So we're still using the radius. In this example, we're going to find the volume of a sphere with radius 7 centimeters. So I write down the formula. Remember, you want to write down the formula every time. And then you substitute. So I'm putting the 7 in for the radius here. And I'm cubing it, which is 343. And then I multiply, since these are both above 1, I could have had a 1 underneath that 343. They're both in the numerator. So I multiply the 4 and the 343. And I get 1372 over 3 pi. I know 1372 is not divisible by 3. 1, because I know where the number came from, 7s. And 4s, which are not divisible by 3, but you can also tell because 1 plus 3 plus 7 plus 2, that's 13. 13 is not divisible by 3. So this is pretty much an ugly number. This is the exact answer. I'm going to go ahead and approximate it and round it to, say, the 10th place. So when I put this whole thing in my calculator, I get 1436.8 cubic centimeters. Now I have a hemisphere, which is half of a sphere. So a lot of times in volume, we'll be looking at hemispheres. Kind of like in area, we did half circles, semicircles. So the volume of a hemisphere is just half the volume of a sphere. So in this example, I'm going to give you the area of the base of a hemisphere. So that's the area of the circle, the great circle there. It's 25 pi inches squared. Notice that it's inches squared because it's area. And I want to find the volume. Well, to find the volume, I need the radius. But since I know the area, I can find the radius. So first of all, I write down the area formula for the base there, pi r squared. And I substitute on the left. See how the 25 pi here is the base area. And then I can divide both sides by pi. So I have 25 equals r squared. Take the square root of both sides, and I get the radius is 5. Okay, so now I know the radius is 5. Calculating the volume is pretty simple. Remember, I'm putting the half because it's a hemisphere. So I put, and actually I went ahead and simplified that first. So I can say, okay, 2/3 pi times 5 cubed. So I get 250 pi over 3 inches squared, which is the exact answer. And you can put that in your calculator to get a decimal approximation. So for further reflection, why should you avoid using 3.14 for pi early in a calculation? The earlier you round, the farther apart your answers are going to be from mine. Okay? So it's best to save that pi button until the very end when you're putting it in your calculator. How do you find the volume of a hemisphere? A hemisphere is half a sphere, so just take half the volume of a sphere. Do you think the surface area of a hemisphere is also half of the area of a sphere? So that's a question for you to think about. And what past math concepts might you need to use when finding volumes of 3D solids? And I'm thinking here more in terms of cones and pyramids.